All right, C says h of x equals x squared minus x minus 12 all over 2x squared minus 8x. And again, guys, first step is always factoring, okay? So take a minute to factor this out. Hopefully by now, you guys are really good at factoring because I feel like this whole unit, all we do is factor. At the bottom, the first thing I'm going to check for is GCF, which is 2x. Take that out. So that means we're going to have x minus 4 left. Now, immediately I can see that I can reduce this. If you reduce it right away, students, that's going to give you a whole at x minus 4 equals to 0. So you solve for it, so x equals 4. But you have to plug it in to get your y. Plug in to get y value, okay? But let me finish this thought here. So reducing it, that's going to give me x plus 3 on the top over 2x on the bottom. So here's our final reduced answer. So you can plug it in here because it's easier than this original. Excuse me. All right, let's plug it in. We have x equals 4. Plugging it in means y equals 4 plus 3 divided by 2 times 4. So that's going to be 7 over 8. So you, my lovely students, this question is going to have a whole at 4, and the y value of this whole will be 7 over 8. Box that up. Then we do have a remaining factor that was not able to completely reduce. That will get us a VA. Take that VA, set equal to 0, solve for it. So your VA, students, is going to be at x equal to 0 because 0 divided by anything is 0. So think about restrictions, right? Those will give us here, x can't be 0, x can't be 4. So all of those restrictions will either be a whole or a vertical asymptote, okay? Now let's look for our HA. Remember, we're going to look for the degree first. Degree on top to see if it's bigger, equal, or less than. On top, half. Degree on bottom, okay? All right, on the top, we have a power of 1. On the bottom, we have a power of 1. So they are the same. If they are the same, that means we will take the leading coefficient of the top. The top currently has a 1 here, a 1 here, and a 2 on the bottom. So that's going to be 1 over 2. Woo, woo, all done. Let's do our last one. And then the last of the last one, you guys are going to do on your own. Okay, similarly, give it a factor. Voila, hopefully you guys got these as factors, okay? So as you can see that you can cancel these immediately, and since they are completely gone, but remember before we reduce, we always have to state the restriction. So we know immediately the restrictions is x can never ever be 5 over 2. Well, that, guys, we just reduce those. So immediately that will give us a whole, aka removable discontinuity, whole at x equals 5 over 2. Well, we have to get the y value. So now if you look at these two, this and this, which one do you want to plug your x into? Well, clearly you want to plug your x into this because that's a lot simpler. So get y by plugging it in, okay? Reduce form, if you can. If you can't reduce, then plug it back into the original. Either way will give you the same y value. So y equals, every time we see an x, plug in 5 over 2 plus 2. Well, 5 over 2, guys, is going to be 2.5 plus 2. So that's going to give us 4.5. So your whole is at 5 over 2, comma 4.5. Box that up. Woo, woo. Okay, so now let's see if we could have a HA question mark. Okay, your HAs, remember, it's always going to be the degree on the top compared with the degree on the bottom. Okay, degree on top. I'm going to write blank. Degree on bottom. I want to see it's bigger, smaller, or not. Okay. Whoa. What if you don't have anything in the bottom to compare, like over 1? Okay, then guys, if that's the case, the degree on the top is 1, If you just have a constant number, that means the degree in the bottom is 0. So that means 1 is bigger than 0. Or you go to the original and you see the degree on the top is 2, the degree in the bottom is 1. 2, 1. It's still bigger. Doesn't matter how you compare it. So because the degree on the top is bigger than the degree in the bottom, we roll up. This is a new one for us. Whoa, case number 3. Whoa, that means there's no horizontal asymptote. Well, the reason there's no horizontal asymptote, no HA. No HA, guys, because look at our reduced form. This is a line. Okay, this is a line. That's all right. So now I would like for you to try this out on your own, and I'm going to ask you for it. And then make sure you guys write yourself some tips and rules so to help you guys remember.